Hey, everybody. Welcome to our Ask the Author session. We're going to be giving away some free books today. We've got the Delta Lake Definitive Guide. Got everybody here who has worked on the Delta Lake Definitive Guide. And we also have questions from you, the audience, we're going to go through as well today. So as we get started, we just want to go around the room and say hello to everybody. And if everybody wants to introduce themselves, we can start off with Prashanth. Tell us a little bit about yourself.
Thanks, Scott. Thanks, everyone. Hello, everyone. I'm Prashant Babu. I'm product specialist at Databricks. I've been in the data engineering space for the past decade, maybe. Yeah. And I've been working on Delta from the time I joined Databricks, like 6+ years now. That's a very brief introduction.
That's a good one. Awesome. Tristan, do you want to go next?
Sure. Hey, everybody. I'm Tristan. I'm a solutions architect at Databricks. I was actually formerly a machine learning data scientist, machine learning engineer, and then found myself building all kinds of other stuff to support my own work. And so I kind of fell backwards into the whole data engineering space. But I'm happy to be here, coming to you live from Clearwater, Florida.
Awesome. Tyler, do you want to go next?
Sure. Howdy. So I guess I have the dubious honor of being the co-creator and one of the maintainers of the Delta Rust project, or sub-project of the Delta Lake project. And I'd say since 2020, when we started it, I've been doing increasingly over time more and more Delta Lake things, trying to shove Rust and Python into every data pipeline that I find.
Awesome. Denny, I mean, introductions if you want. I mean, people know who you are already, but if you want to
go. Sure. Hey, everybody. Hi, I'm Denny. Really glad to have this crew of folks here to help write the book. Yeah, and longtime Delta guy. So there we go.
Awesome. And then I'll finish with myself, I guess. I'm Scott Haynes. I've been in the Spark and Delta community for a long time. Happy to write this book as well and work with everybody here to get everything out the door. So I'm just going to kick it off. Like we have a couple questions that came in, and one of the first ones, anybody who wants to answer this one can go into it. It's more of like a streaming topic. So the question is, hello, it's like I've got a lot of experience with batch processing, but I've recently been looking into the streaming first approach. I have no problem in streaming data into initial lakehouse layers via trigger available now, completing tasks like schema validation and cleansing, even merging with for each batch. So typical kind of bronze to like silver in the medallion architecture. Where I come unstuck is from the complex transforms and joins to build facts and dimensions. So the question really is it better to stick to traditional batch operations at this point rather than relying on stateful streaming operations, most likely as we're getting into the gold tier within like the medallion architecture. So does somebody want to take a first stab at answering this question? Maybe Tristan, call you out.
I'm still thinking through it. I'm a little slow here. So, I mean, we're talking about complex transformations and joins. So we're looking at like kind of the middle layer of your data architecture for the most part. At this point, it's kind of actually more of a middle ground area. So what we see a lot of from people is using Delta Lake also as a stream source in addition to a stream sink. And so like you can actually stream by version number rather than using a smaller trigger like you would see on Kafka. And so that's actually probably one of the most common ways that I see people doing it, but it kind of depends on your data volume. If you have a lower data volume table that's getting streaming inputs into it, then you can certainly pick that up on a batch process and just kind of run it daily or as needed.
And if we take that a little bit further and we think more about like also, there's a lot of, so as people are kind of trying to figure out like, you know, at what point in the medallion architecture do you start to kind of get back into like the older, like, you know, it's kind of more of like the traditional star schemas and things like that. Like if I think about like facts and dimensions being kind of split up, usually it's to normalize a table, we're creating some sort of harmonization, and then things are kind of, you know, becoming more kind of join heavy. And so like, if you think about like streaming in general, then joins are something that becomes something that's more, you know, it's like, oh, well, we could do that, but would we want to do that? And I think like in terms of, you know, any kind of architecture, right, there's that need for hybrid. So does anybody have any other kind of points on suggestions for anonymous question number one?
I think there's some interesting parts about the Delta protocol itself that are important to consider with a streaming workload, especially like how frequently changes are coming in. One pattern that I've seen that's caused a lot of people trouble with moving from batch to streaming is having too small of commits on their Delta tables, because you've got your data files and then you've got your transactions that are being committed. And if your data files are like in the megabyte size and they're happening every second, you're creating a transaction for like each a very, very small batch of data. And there's some tunables with Spark or with the Python and Rust implementations that you can use to improve that. But that also means that when you're joining, as an example, that you are also like you're loading a lot of different transaction logs for every table that you see. I saw one organization a couple of weeks ago where they basically blew out dimension tables like wider than I think I've ever seen. We're talking about like hundreds of dimensions, and then they wanted to join that all back in, and they're having performance problems. Well, they're having performance problems because they had their Spark job then had to load the transaction log for 100+ different tables just to perform the join. And so the performance improvements that they would get by using Delta Lake, as an example, they had erased by just splitting things out way too granularly. And so the way that Delta works is something to consider with your batch size and sort of how much you break out or split out bronze and silver tables.
I think that's good in terms of like the advice, because of like the cost of like loading in like the Delta snapshot. Also on top of like if we think about like this as like kind of questions about architecture, there's that, there's sort of like there's the denormalized approach of it kind of going back to like that, it's like big fat table, big wide table, whatever you want to call it, right? Like one big table. It's like, one table to rule them all type thing. If you want to kind of go in towards like more of like the streaming approach for a lot of this, you can do that and kind of incrementally do all the join processing so that you end up at having, essentially like a streaming table that is, representing gold. But the effort to do that and to kind of keep up to date with that isn't as easy as doing kind of more of a hybrid like approach. So I think it's depending on like, everything's nuanced, right? It's the size of the table, it's the number of those joins and everything else. Like Denny or Prashanth, do you have anything you want to add to either suggestions or, things that you've seen in practice as well?
At least for me, nothing in particular. I only would do like the +100 what Tyler called out, which is the fact that, right. I guess maybe what I could add potentially to it is that for some folks that end up having lots of small little transactions like that, what you end up doing is running more times that you end up running a bunch of vacuums using a second cluster off to the side to basically remove all those little transactions as you're actual optimizing as well. So that way you don't have a result of a lot of small little files, and your transaction log doesn't become this gigantic behemoth. And so, but be very careful on doing that. If you can avoid that scenario in the first place, that's probably the preferred option. But if you do need to go do it, then that's actually a common approach.
All right. I'll move on to our second question. So the second question comes from another anonymous person. So question number 2 is, where does Delta Lake store data? Anybody who wants to pick this one up, you can go. And there's a couple different answers for this one. So I'm asking the question. Tristan, I'm going to call you out, or Prashanth, I'm going to call you out because you didn't get to the nose fast enough.
All right. I don't do the nose, so I guess that's the price I pay. So I think it varies quite a bit because it depends on where you're actually doing your processing at. I mean, you could be using, for the most part, cloud operations. So you're going to be looking at S3 or ADLS or Google Cloud Storage. But also you can run Delta Lake locally. Like I play around on my laptop all the time. And so it's literally running off of my hard drive. But basically, it's whatever you've set up as the storage layer for your processing tool of choice, because you're not limited to any particular processing tool. There's so many open connectors at this point. There's a wide array of options for storage.
I think that's pretty much the perfect answer. So I think we could move on from this one. But for anybody who's looking at connecting new storage as well, I don't know, Ryan. I don't know why I'm calling you Ryan. Tyler, go. The R is throwing me off. Continue. It looked like you were
Ryan
saying-
Tyler. What I was going to say is the way that, like, how and where Delta Lake stores data has evolved over time. In the book, there's a good overview of like how exactly the transaction log is stored, how exactly data files are stored in Apache Parquet. What's kind of interesting about the Delta Lake protocol is the transactions don't have a relative path. They have it can be a URL. And so shallow clones, as an example, allow you to have your Delta transaction log stored in one location and actually point to data files elsewhere, which is a really novel use of that. If you don't have the book, or if you don't go thumb through the book on Denny's blog, he actually wrote, I think, a pretty good overview. It's called A Peek into the Delta Lake Transaction Log, which I'd recommend. And then one other thing on storage that I wanted to mention is in the last 6 months, AWS S3 has implemented a primitive operation that wasn't present before. We often refer to it as put if absent. And the lack of that primitive required an external coordinator for concurrent writes on AWS S3. It's probably one of the most frequently asked questions in the Delta Rust channel is when we will support conditional puts in Delta RS, which would allow you to have much more concurrent writes without any external coordinator, like a DynamoDB sort of thing. But Cloudflare R2 supports it. Minio supports it as well. There's a couple others that support it. And so there's been a tremendous amount of evolution on how data is actually stored, or what's possible with Delta Lake on S3 and other S3-alike storage providers. That's it.
Awesome. Thank you for that. I think that's super helpful as well, and it does come up all the time. All right, so moving into question number 3, again from Anonymous. I'm just gonna keep on saying that every time. We don't know who these are from, so somebody has asked this. It's not just us making it up. All right, so we have some append-only tables that we write to using Spark Structured Streaming. So the question really is it safe to significantly reduce the value of the Delta log retention duration in hours? We could go wrong here. The motivation for wanting to do so is limitations in Azure with processing very large transaction logs. And so I think with this one, I'm going to just assume, for the sake of us answering these questions, that it's an append-only table using the Delta feature like append only. And so for people who want to answer this question from the group of authors, does anybody want to take this one? I think there's a couple different kind of competing ideas like within like this question. So if we want to start off and just think about like reducing like the value of the log retention, if it's append only, there's 2 different ways of answering this, because one's an append only table using the Delta feature for append only, and the other would be that it's essentially just like a stream of log segments or anything else that is then append only. So does anybody want to pick up one side or the other of this question?
Pick on Prashant.
Prashant, go get it.
I'm not sure. I was just trying to think through. I mean, if it is append only table, probably we can continue to write to that table, and behind the scenes with an optimized job, probably we can continue to compact the files as much as possible. That should be a better solution than looking for any other solution, at least from my perspective.
And if you think also about like the log retention duration, if it's append only, and like if we're using kind of the traditional, like the real append only, like Delta table, we can write to it. We can't delete from it. We can't do anything else. We can essentially just go and drop the table at the very end of it. I don't think that's what this question is asking about, because a lot of times those tables are for like kind of one-time imports. It's kind of like that landing zone pattern. But if we're thinking about just append only in general, I think there's also that question of like how long somebody wants to time travel. How long do you want to retain any other version of a given table? Because that's always like the bigger surprise when there's just that kind of expectation. It's like, oh, I can go back in time, I can time travel, But if there's no records for that, then it never existed anyways. So does anybody have any recommendations on any kind of novel ideas for figuring out how to come up with like a sane vacuum period, same amount of time for time travel? Seeing some nodding. Tristan, you want to go?
Yeah, I don't know if this will help or hurt, but I think there's actually a couple different areas you need to watch out for on this. So one, and this is not necessarily obvious or applicable to all cases, but you want to not think of time travel as like an infinite retention bucket. Like you don't want to stack up, a year or two of table history inside there by extending that duration, because it can cause performance issues. If you're doing something like that to maintain like, snapshots in time of your data, you should probably set up a specific storage strategy for that. Coming around to the other side, though, you also don't necessarily want to set that too short, and this will kind of depend specifically on your application as to what defines too short. But you usually don't want to go like, I've had people ask about like, can I make it so it's targeted specifically to the very last version rather than a time window? One, that's almost impossible to do just by the nature of it without some extended under the hood work. But two, you always want to maintain at least like a little bit of history there if you can, because something will happen at some point that you're going to want to be able to roll back. So you don't want to trim your horizon off in such a way that you're not going to be able to do that. Like something will always come up at some point, or I fudged on the keyboard and had a typo slip through to production. Inevitably, it will happen. So best guards, keep at least some barrier on the one end, but also don't try and go forever with your time travel.
Denny, do you have anything to say as well?
Yeah, I mean, just to add to what everybody's saying here, I mean, what it boils down to is when you have like a log retention duration of, let's just say, hours, right? What you're implying strongly is that you don't need to go do any form of time travel going back beyond, let's just say, 4 hours, if you set it for 4 hours. So if that's what you've done, understand that's what your use case is, right? That you can't go backwards in times. Now, the great thing about append-only tables is that if you're only running append-only, for example, for the configuration, you don't really need to time travel that much, right? Because you're just literally adding new data, and so basically you're tracking it anyways. And so that's the one scenario I'm a little bit more comfortable, where you don't bother having like a very large log retention time. So that way, basically, your log file, the _delta_log folder, isn't just full of JSON files and Parquet files that are trying to keep up. That actually is to a distinct advantage. But again, it goes back to that point of that. Understand then that's what you're doing. Understand that you're not going to run a merge on this thing. You're not going to do a delete on this thing. You're not going to do any updates. This is just pure adding new files. Then it is a relatively safe, again, provided y'all know that's what you're doing. Right. And the only reason I'm saying that is because I've done that myself, where I forgot that I was doing it. And then, oops, I made the mistake. So a dumb way of doing a solution, like this is the poor man's solution, is I went ahead and renamed the table. I think I did AO or append only or something like that, where basically it's like, yeah. Oh, yeah, that's right. That table's append only, right? Now, not saying that was the best move that I've done, but I'm also saying it at least did remind me that's what I was doing. So.
No, that's awesome.
One of the things I wanted to throw on this, if you're using the Databricks platform as an example, you can get query history from Databricks SQL endpoints. Or if you're not using the Databricks platform, if you're using Glue or EMR, or I mean in Azure, I actually don't know what the Azure stuff that might interact with Delta would look like, but you can ingest object access logs. And depending on what is actually running your queries, you may be able to get query history out of that. And so one of the patterns that I've done for a lot of tables that I'm not sure, like I know I needed to tune, but I'm not sure how I need to tune it, is I'll go enable object access logs for that particular table, and I'll watch it for a period of time. Like I'll ingest that data, and then I'll run some analysis on the actual access logs to see what are people actually doing. Ideally, if you can get query history, that's even better, because then you're making an informed decision. One of the challenges that I've experienced a number of times is what people need to do in terms of time travel is very subject to their application, as you or Tristan mentioned, I can't recall. And it's also dependent on the volume of data. Like it's table by table. Like it's very difficult to apply a policy across your entire Delta Lake. And so object access logs or query history can be really useful. It can be expensive to leave on for like every table, but if you know I need to answer a question, turn it on for a week and see what happens.
That's awesome. That was a very good answer. Tristan, you go. You got more.
Yeah, I want to add one more thing on because it's closely related to this topic. Especially like the more transactions and the larger the size of the table that you see, don't fall into a trap of thinking append only means no maintenance is required ever. Like you still need to do things like vacuum operations and stuff, because just through like the occasional failure of a cloud provider, you will wind up with just dead files hanging out in there. So you still need to make sure and do those kind of cleanup operations from time to time.
Awesome. That I'm like, that's a good segue. I'm like that's a good segue into the next question, but it's actually not, because I had my screen covering the questions. So the next question is more on Uniform, but also at the same time, the comments that are coming in live, there's a question essentially about like why use Delta over Iceberg or Hudi. And so that also I think is kind of a segue into like why use Uniform as well. And so I'm going to pose this to anybody who wants to answer the question. Noses or not noses. Denny, do you want to go?
I'll tackle this one. So for starters, we're not going to be doing comparisons between the three because each has their own strengths. And so Iceberg has its awesome use cases, Hudi has its awesome use cases, and so does Delta Lake. Okay, the key thing that I like to remind everybody is like in the end, you got to be using a lakehouse format. Okay, that is the most important aspect, because if you aren't using one, then you're using a proprietary system, which is more expensive, or you don't have access to the systems, to the data and especially the code base that's being used to operate that system. So use one of the three. Now, obviously, we're a tad bit biased toward Delta Lake, being authors for Delta Lake. So just a tiny bit, right? But again, we're friends with a lot of the Iceberg folks, friends with a lot of the Hudi folks. They're on board with us too. We actually trade information back and forth on a regular basis. So there's, again, we all have our usefulness, and that's exactly what we're going to stick with. Okay. Now, why Uniform? Now, specifically why Uniform is because everybody has asked all three of the lakehouse formats. Whatever one you chose it for a good reason. So I'm not going to debate the reasoning for doing it. Okay. You chose a lakehouse format. Excellent. We're happy with that now. But because there are some differences between how each lakehouse format operates, you, the user, are now having to deal with that, like how to migrate or how to translate. And more times than not, it's not about migration. More times than not, it's about translation. So that's what Uniform is really about. Uniform is really there to make it easier. Now, some people will like the version of Delta Lake Uniform, which Delta Lake basically underneath the cover will generate the metadata for Iceberg. It's been available since Delta 3.0, 3.1, and Hudi's metadata was generated was around Delta 3.2, if I recall correctly. Because underneath the covers, we're all using Parquet files. Okay, that's it. All right, it's just how we operate and manage the metadata on top of that. That's actually the major differences between all three systems. Now, people can get technical and tell me also, well, in the case of Hudi, they also use Avro. In the case of Iceberg, they also use other file formats. Delta only uses Parquet. This is all correct, but fundamentally, it is about a file, most commonly Parquet underneath the covers, and then the three systems are how we deal with the metadata slightly differently with each other. Okay. And again, each one has its pros and each one has its cons. And so Uniform, and also I'd be remiss without mentioning another important project called Apache Xtable, are there to specifically help provide basically a layer on top that abstracts away the problem of the metadata, basically to generate the metadata for each of the other file formats. So that way you don't actually have to worry about, oh, I have a Hudi table, but I'm running this, Python code to query the data. You have something like Uniform or something like Xtable. The premise is to go ahead and you, the user, don't actually have to understand which lakehouse format you're using. Just as long as it's one of those three, we're actually able to automatically translate. So hopefully that makes things a lot easier for everybody. And this is important because in the end, most people don't want to spend their time focusing on, which lakehouse format you're using. They want to take the data that's in their lakehouse format and do something with it. That's what they want to spend most of their time on. And especially in the day and age of Gen AI, they want to Gen AI that stuff. Okay. They want ChatGPT that stuff or whatever it is that they want to do. Exactly. The magic, right? But the context is because of that, then this allows you to focus more on that aspect or more on that particular problem than for you to actually be worried about the Scala code underneath the covers to do the metadata. Okay. And so I think most of us here are happy to say, yeah, let's not do that anymore. So hence the reason for uniform. And again,
I wanted to add on that very diplomatic answer. Well done, Denny. Your media training has paid off. Bias towards Delta Lake, obvious. One of the things that Uniform is really useful for is to try out AWS Cloud Native services that speak Iceberg natively. I've found that oftentimes I want to experiment with a new feature or functionality that's come out in AWS, and it starts out supporting Iceberg first because that is a preference that AWS has made. So like in Athena or parts of the Glue environment, Uniform allows me to point those cloud native tools directly at the same underlying table, because then they're just reading the Iceberg metadata. And so it does allow a little bit more flexibility with your query engine. It also allows you to experiment with other things and just sort of see what experience you like. I've also found Uniform really useful for exposing, with those cloud native tools, for read-only use cases. All of our ingestion writing pipelines are still Delta based, and it will continue to be so. But having Uniform metadata alongside the Delta metadata allows you to sort of pick whatever query engine or reader on top of that is going to be best suited to the business's needs, that sort of thing.
Both great answers. Do we have anybody else want to offer some insight or anything else like that? Otherwise, we can move on. So I feel like that was pretty well covered. So thank you. All right, let's see. So moving on to anonymous question number 5. Is it possible to use Delta only as a format without having to use its built-in catalog? Delta takes a lot of time to create and insert a few rows for unit tests. Is there any test mode or something like that to use for unit tests? This is like a very many part question. So let's just answer the first one. Can I use Delta without any sort of Delta catalog or anything else like that? Who wants to pick this one up?
That's an easy one. Come on, chime in, guys. Yeah. So a lot of the examples for Delta Rust or Delta Lake, the Python package, don't use a catalog at all, actually. Somebody may have actually broken catalog support in that library. So you can't really use a catalog directly with it. In Spark, you're typically referring to, in a Spark SQL command, you're referring to delta.backtick S3 path or whatever. The catalog really serves to be a discovery mechanism. It's very useful for users that are needing to discover tables or properties about those tables, but it's not necessarily required for the function of Delta Lake, whether you're using Spark or the Java standalone reader or Python or Rust. But there are benefits to using a catalog. So the answer is yes, but if you don't use a catalog alongside a data lake, you do lose some benefits.
Yeah, actually, that covers that, actually, honestly.
Yeah.
That's pretty much it. You have the benefits of having it, but it's absolutely 100% not required. So,
Yep. Either take everything into your own hands, manage everything, don't worry about it, hopefully nothing breaks, or use the catalog. We're going to move on.
Yeah, I never run it with the catalog when I run it personally, whether it's in Spark side or on Rust side. Same difference to me.
Yeah. Also, I think especially given the question is also kind of catering towards the unit tests and everything else like that, why not? Going to set up a lot of things locally to have your catalogs and everything else can sometimes be a little bit more difficult versus just having raw paths as well. And whether or not like it takes a lot of time to insert a few rows, I think is kind of subjective. And maybe there's some tuning, other things that need to be done like within those unit tests to make the unit tests run faster. Maybe things are running in synchronous order that could be parallelized as well. Not parallelized in the sense of like not moving, but parallel operations in the unit tests as well.
In Delta Rust and Python, we have just a built-in thing to just create a Delta table in memory for a lot of our integration tests. That is part of like the public library. On the Spark side, can you just create a in-memory Delta table like with it, like in-memory file system sort of thing?
That's a good question. I don't know.
Yeah, I mean, you can definitely, like, when you go Spark, typically when you're creating a memory, you're creating a Spark data frame in the first place anyways, right? So by definition, when I want a proper Delta table, right, I still technically need to write it to disk, write it to object store, and then reread it again to be truly seen as a Delta table, because otherwise I'm really just doing the quote unquote transactions to the Spark data frame. That's all I'm really doing, right?
It's like the write mode memory for that.
Yeah, at that point. And then of course, then we start saying like we start tossing a Luxio, so we have in memory. We have an in-memory file system, so that way we can go ahead and write to there if we want to, and then theoretically we wouldn't even need that. But then there's still the issue of transactions, and then we get into debates about how we talk about Arrow versus Alluxio for that purpose, and then this becomes a whole other debate that's going to go completely down down a rabbit hole that I don't think any of us want to go into right now. So let's.
Hey, it's a Tuesday before a holiday week. It's all good.
All right, let's do it. No.
Yeah, to unit tests or bust, right? It's like Tristan, did you have something to say?
I was going to say I think of it pretty similarly, but going way beyond just Spark too. Like, and I know in several of the examples for the book, we used the quick start for Delta, but I think we went out of our way to try and do a lot of direct file operations through several different like choices of language, although everything for the most part falling down to Python or SQL. But like we used Delta RS, we used SQL, we used the Delta Lake APIs, and used lots of examples. But really, I think of the in-memory thing as being outside of the Spark environment. Just like for me personally, whether I'm using Daft or Ray or Polars or just plain old Pandas, like all of those, it's kind of the same thing. Like you have this concept already of an in-memory data frame. Like I don't really need to do something in addition to that on the Delta side. Like it's really more about my storage and access.
Awesome. That was great. All right. Let's see. I think there's no, everything else is essentially more about like about tests. So if whoever asked this question, if they want to reach out like on like LinkedIn or anything else like that, you could DM me, Denny, anybody else. You go into a little bit more, or just hit up like the Slack channel for Delta users and ask the question, like the general questions. I can pick it up from there as well, because I think unit testing is an interesting thing that a lot of people skip over, and being able to like effectively test, I think, is a really great thing, especially for kind of like any data engineer, any software engineer, everybody. Tests are how we make things work. And all right, so now we're going to start moving into additional kind of questions that were popping up as well. Does anybody want to answer the question between the difference between a checkpoint and a snapshot?
Actually, I think you should answer that, Scott, since that is your street, that is your baby.
All right, let's go. So
do it.
If I get a checkpoint is keeping like my transactional state. So in a use case of essentially going stream from Delta to Delta, like I've got an upstream source that's a Delta Lake table, and I'm writing to a new Delta Lake table. I'm essentially processing transactions. And so if a transaction occurred and I processed it, and then I wait some time and I go to process again, but my streaming job fails, I've got a checkpoint that tells me where I last successfully committed or aborted within like my processing pipelines. So I've got checkpoints that keep track of the last like reservoir version, which is like the internal version of the Delta Lake table that I last did process from. So when I start up, I can read from it again without having to worry about where I did leave off. So you can think about this as like it's stateful processing within stream. The snapshots themselves, I think about this more in terms of like a Delta Lake snapshot. And a Delta Lake snapshot is essentially like a current version of a table or the current version of a table at a specific point in time if I go back and I time travel. So if my current version is, say, version 100, and I've kept enough history to go back to version 50, both version 50 and version 100 are both separate snapshots at different points in time that represented like the current state of that table at said point in time. Anybody else have more to offer?
With Delta Rust and Python, we've started to use the term snapshot in our APIs to make it more explicit that when you load a Delta table, that it is always a snapshot, because you never know if the Delta table has been written, after you've loaded that state. So over the last few versions, say the last 6 or so months, we've been increasingly referring to things as snapshots, because the version, like anytime you load a Delta table, that's only a snapshot in time, like forever, like unless you can guarantee that nobody else has written it. One of the things, I'm not sure if Avishek was asking about Delta's table checkpoints or streaming checkpoints. Because in the Delta transaction log, we also have the concept of a checkpoint, which is just an optimization. It's not something that you actually have to have on a Delta table. I discovered a Delta table a couple of weeks ago that had like 1 million versions and checkpointing had been disabled. But in the Delta transaction log, a checkpoint is basically just a summation of the transactions up till that version. And by default, Spark and Delta Rust and Python will add a checkpoint. I believe it's every 10 versions. They'll just create a checkpoint Parquet file, which you'll see in your _delta_log directory for your table.
For those of us who used to be in like audio or video streaming or anything else like that, there's also the notion of like P frames and I frames. And so it's kind of like a P frame is a full frame, full copy of what happened, and everything else is kind of like these interstitials. And so if you lose a bunch of stuff, you can still go back to the last full frame and replay it as well. But I feel like the naming is always hard contextually as well, because you'll say checkpoint and then it means a bunch of different things across the board. I play video games. I like to think of it as like a save file. It's like, this is where we last saved. You can pick up a game from here and kind of move on. All right. Anybody else have anything else to add to this, or I can move on because we've got a lot of we've got a bunch of other stuff coming in.
Yeah, we got a bunch of the questions. I think we've got like 7 or 8 minutes left too. So yeah, let's just dive into it.
Cool. Avishek has a bunch of good questions.
Yeah, I know.
Let's just go into some more of this. So if you think about schema changes, how are these managed in Delta Lake?
All right. So I got it. So long story short, the Delta transaction log actually contains the actual schema change. So if you actually parse the actual Delta log itself, then what you'll actually see is there's an additional schema add action that's actually added into the Delta log that actually contains what the old schema was versus what the current new schema is. And so the idea is that the new schema is there, so you can actually go ahead and figure out, oh, that's what happened. So from that point onwards, any new files or data that's added into the system, it actually knows how to take into account of the schema that was just changed. So even if the schema is slightly different from the Parquet files that were, for example, already inside there, it's okay because we actually are stating here's what the schema of the table actually is. That may or may not match what the Parquet files themselves have.
Anybody else? We could also go into some of the interesting points about that as well. If you think about like column mapping or being able to delete a column, it's always hardship if you're just using kind of straight Parquet. So does anybody want to pick up what the problems were before having essentially the separation between schema and the underlying, Parquet file itself? What sort of benefits are added? We can also skip this.
I like to pretend that nothing existed before we had the schema definitions in Delta, and like the before times we just don't need to discuss, Scott. I think
we don't have to,
for everybody's benefit.
Yeah, it was a pain, and none of us loved it. And so now that we don't have that, I mean, we can add the fact that column mapping allows us to add additional like underscores and stuff like that directly to the name. But outside of that, I'm like, yeah, we're good. We're happy. This is the way it should be now.
One of the things that I think is worth mentioning is schema evolution is supported in the Delta Spark, Delta Rust, Delta Python. And that's an optional thing when you do a write. It does create that same metadata transaction that Denny was talking about. But when you use schema evolution in any of these libraries, it basically is going to look at the schema of the table and the data that you're bringing in. And if the data that you're bringing in has additional columns, it will evolve the schema of the underlying table with additional nullable columns so that you can still query back in history. They just look like additional nullable columns. So older records will have nulls in all of those columns, and then newer records will have the things in there. But you don't have to use schema evolution. You can just run the DDL, like run DDLs separately from your writes if you so wish.
Very good answer. I like to do both things. I also like, I think there's something nice
You
about
mix your
knowing-
chocolate and your peanut butter.
Oh, for sure. Or the Nutella, whatever I'm feeling that particular day. But I think it is like, I think
Definitely Nutella.
yeah, it's always nice to have like some sort of governance as well. Like it's like, if we're going to go add a bunch of things, because if I think about like merge schema true and just, you know, sometimes we have problems with naming, and you might get like lexicographically close naming for columns that are a little bit off. And so we don't have to go into like data quality that much, or like, you know, why we would have something like that. But checks and balances are always good.
You know, since we are making this a series for Ask the Authors, maybe what we can do is we can literally make one of them just about this particular topic, because I'm pretty sure between the five of us, we can probably go a full hour on just that one topic.
I used to live in that world that Tyler was so dreading to talk about, in which it was just Parquet and our best, just us doing our
ages.
best in the dark ages. We had candles. That was our light source. Okay.
Okay. Get out of the trauma, my friend.
Out of here. Out of the
You got to
trauma.
deal with it, baby.
Almost having vacation. Almost vacation. All right. Let's see. What else do we got here? All right. So Abhishek, more of his. These are all great questions as well. So we'll go over here as well. So if you think about like auto compaction, auto optimize, how is it useful? I guess generally, like whether it's like optimized writes, or we're just, you know. Prashanth, do you want to take this one?
Yeah. So basically we have two options. One is optimize writes and auto optimize. So basically we have two options. One is writing the files. I mean, when we are writing the data to the underlying storage, at that point that kicks in and tries to reduce as many files, reduce the writes to as less number of files as possible. So the first option is auto compaction, which will occurs after the write to your table has succeeded. So that essentially runs in parallel on the same cluster once the writes are complete. That's about auto compaction. So what we are trying to do here is trying to reduce as less number of files as possible when we are writing. Again, it is typicable with a couple of options in Delta Lake. The second one is more on optimized writes. Now, previously with the classical writes, usually what used to happen is like one core was writing to its own file or multiple number of files. Now with optimized writes, we can ensure that a single core, if it is writing to a file, we can ensure two cores are writing to a small file on the VM, and then there is another process which runs in, which tries to compact those files into a bigger file. So essentially, again, trying to reduce the too many small files problem with both optimized writes and auto compaction.
Perfect. All right, let's see. Moving on, I'm just going to ask a question that I think we had talked about as like a group beforehand, given that we're like down to the wire right now. But what is something that you wanted to put into the book, but you didn't get the chance to, it didn't fit, or we just ran out of time, which I guess is the same thing as like not having the chance to. Does anybody want to talk about like what they would have liked to have done with unlimited time and, you know, all sorts of things. I can start calling people out too. Let's start with Denny.
Well, in my case, so if some of you may or may not realize that this book is the second version of Delta Lake Definitive Guide. So the first book, I was famous. The reviews trashed me, and I agree with it. By the way, let's be very clear about this. Okay, so this wasn't wrong. That I went a little too deep, too fast. So by chapter 2, we had already went into the internals of how Delta Lake worked, and everybody's going, dude, this is chapter 2. You don't do that. And so if I had the time and the option, I probably would have went even deeper again. But I believe I was slapped on the wrist by everybody here and the editors to say, Denny, stop. You can stop now. You can stop now. But yeah, so that's if you would have tolerated, the audience would have tolerated, I probably would have done that.
Awesome.
And to be fair, everything Denny wrote that didn't make it in the book, for the most part, made it onto his blog anyway. So it's out there.
Yeah, but that was still high level. I wanted to go deeper.
Denny really wants to expound on the Zen and art of lake house maintenance. Really likes to get under those sediments. I didn't. There wasn't anything that I was like, gosh, I really wish I could shove into this book. But I kind of like in a similar vein to Denny. I'm a huge fan of Apache Data Fusion. I think what the team that's working on that is doing is really, really interesting, to where I almost want to write or read a book about here's how Data Fusion sits on top of Delta Lake is really interesting. But then there's this whole world of really fascinating data processing and performance optimization logic that Data Fusion has been experimenting with, implementing, that plays very nicely with some of the predicate pushdown or performance optimizations that Delta Lake has. And so diving deeper into that is something that I really would love to do, partially because I don't know if y'all felt this way, like writing something like a chapter in a book forces you to really research and understand, make sure I'm absolutely correct in what I'm saying. And so it gave me a lot of opportunity to go through the different layers of Delta Lake and I think this is why, but is that correct? And so the research that would be required for that Data Fusion Delta Lake integration would be really, really fun.
Awesome. Anybody else? Tristan? Get your
From
mic
my
on.
perspective, I feel like not so much a complete omission, but I think we had to make a lot of trade-offs given the breadth of the larger Delta Lake community, that really any specific data stack, you could probably rewrite the entire book with that in scope and recreate all the examples. And really, there's so much involved that Tyler, I think your stuff came the closest to it, but everything kind of actually deserves that attention because there are a lot of nuances to a lot of these things. And sometimes you have to dig in, you have to do some additional research, dig into the docs. And I know we did try to help out with a lot of those links and stuff, but really there's so many tools, there's a lot we could have, this could have been 5 times longer as a book, but I know our editors would have been really, really mad.
Prashant, is there anything that you would like to have had in the book that didn't make it?
I think we had a lot of content, and it was also edited quite a bit by Aurelie. So most of the content we thought which should be there is already there, I guess. But as others mentioned, if we continue to write, I think it will go on forever and ever.
Awesome. I'll finish up all these thoughts. It could have, I think the interesting thing was that we started writing for Delta 2, moving to Delta 3, and then slowly moving into Delta 4, during the course of the book as well. And so for me, I think there was that endless want to keep on adding more and more and more and more, getting into type widening, getting into some of the new stuff that is just out, or it literally dropped the week of us being completely frozen, feature frozen for the book. It's okay, well, we just won't have that in there. And so it's interesting if you think about a definitive guide being, it's definitive, but it's always like books will always be about a year older than like what's current by the time everything comes out. And so I think for me, there's always like, you're kind of chasing that, like, what if we had this? What if we had that? What if there was more time for X, Y, and Z? But I think nowadays it makes it easy to, we can just keep on adding more content online and, filling in the blanks and the gaps. So cool. I think with that, I think we're done. Anybody else have any last things to say, or we can just roll into the next?
One thing I just want to call, keep asking your questions in LinkedIn and YouTube, because since this is a series that we're doing, we'll actually try to build it up based off the questions you've got here. There's a lot of really good ones that are coming at the last second, so we don't have time to obviously tackle these today. But for the next one that we're planning, yeah, absolutely, we'll use these as the basis for the next set of questions. Okay. Yeah.
Awesome. With that,
if I can add one more
you go.
parting thought,
Yeah.
Scott, if that's okay.
Yeah, please.
The Delta Lake project is open source. It's an open community. The protocol is open. Should you be so interested, so motivated, we always need help writing documentation, adding new test cases. If you see something funky using Delta Lake with your, experimenting as you go through the book, or if you're using it in a production environment, like jump into Slack or GitHub discussions. Like, the reason Delta Lake has matured so much over the last few years is because more and more people have really started to invest their time and efforts in making Delta Lake what it is today. That's it. Now I'm done.
Awesome. That's a great way to close. All right. With that awesome ending, we should have just cut it, because now I'm just mumbling. So now we're done. We're done. Thanks, everybody. Bye.
Thank you all.